Unit 1, Topic 3 notes. We're going to continue talking about systems of linear equations, which are two or more linear equations written with the same variable. Today we're going to talk about the solving method titled elimination. So elimination means to get rid of. Mathematically, that means we want to make 0. Because if I do 3x minus 3x, I get 0 x's, which is actually equal to 0. So I have eliminated my x's. So that leads us to opposites, which are numbers the same distance from 0. So if we think about a number line where 0 is in the middle, 1 and -1 are opposites because they're both 1 unit away from 0. 2 and -2 are opposites. 3 and -3 are opposites, so on and so forth. So opposite numbers when added together are always going to make 0. So we're going to utilize that fact in this elimination method. So we're going to start with an example where the opposites are provided for us. If we look at our two equations, we have 2x plus 3y equals 11, negative 2x plus 5y equals 13. We can see right away that we have opposites, 2x and negative 2x. So to use the elimination method, what we're going to do is we're going to add up our two equations. They're both going to be written in standard form, which makes them nice and lined up. Our x variables lined up, y variables are non-variable terms. They're all lined up and ready to add together. So if we do 2 plus -2, we get 0x, or it just eliminates. We don't have any x variables. Then we move on. 3y plus 5y is 8y, equals 11 plus 13 is 24. So by eliminating our x variable, all we have left is our y variable, which now we can solve that equation. 8y equals 24. We undo that multiplication with division, divide both sides by 8, and we get y equals 3. So now we know our y coordinate in our solution, but we still need to solve for our x coordinate. So to do that, we're going to pick an equation from our original set. We can choose the top equation or we can choose the bottom equation. It does not matter which one you choose. I'm going to choose the top one. So we're going to use 2x plus 3y equals 11. Now we're going to go back to that substitution method that we talked about last topic. So we know that y is equal to 3, which means I can replace my y value with 3. So I can change this y into 3. Make sure you substitute using parentheses. We can solve this equation. So we have 2x plus 3 times 3 is 9 equals 11. Undo that plus 9 with a minus 9 on both sides. We get 2x equals 2. And lastly, divide both sides by 2. And we get x equals 1. So our solution is 1, 3. That's where the two lines would cross. All right, so now we are going to do an example where the opposites are not given to us. Now in order to make opposites, we are going to have to use the multiplication operation. So to do this, we are going to look at our variables. So we have 6x and 2y. Or 2x, excuse me, and we have 5y and 3y. So I'm going to start with this 6x and 2x pair. So I'm going to ask myself, using the smaller number 2, can I multiply 2 by a number to make the opposite of the bigger number? So to make the opposite of 6, which would be -6. So 2 times what number gives me -6? Well, I know 2 times 3 is 6, and then a positive times a negative gives me a negative. So I can multiply 2 by negative 3 to get me negative 6. Now, if I do that same process for the y variables, if I say 3 times what number gives me 5, there's no whole number that would answer that question. So we're going to stick with that first option of multiplying 2 by negative 3. So to do that, we do need to multiply the 2 by negative 3, but we have to actually multiply the entire bottom equation by that negative 3 value. When we do that, we just distribute the negative 3 to all the terms. So negative 3 times 2x is negative 6x, negative 3 times 3y is negative 9y, and negative 3 times 5 is negative 15. And now that we have done that multiplication, I'm going to rewrite this top equation right below that. 6x plus 5y equals 19. And now I can add up my two equations, and I can see right now that I have those opposites, negative 6, positive 6. Those are going to eliminate, and then we can add up the rest. Negative 9y plus 5y is negative 4y. And negative 15 plus 19 is positive 4. And then the last step is going to be dividing by that negative 4 on both sides to get y by itself. So we do 4 divided by negative 4, and we get negative 1. So I know in my coordinate point, my y value is negative 1. Now we need to solve for that x value. So we're going to go back up to our original two equations, and we can use the top or the bottom equation. It does not matter. I'm going to use the bottom equation this time. We'll switch it up. So I'm going to rewrite that bottom equation as 2x plus 3y equals 5. Well, now I know that my y value is negative 1. So I'm going to replace my y value with negative 1 in parentheses. And now I'm going to solve this equation. First off, 3 times negative 1 is negative 3. So 2x minus 3 equals 5. Then we can undo that minus 3 with a plus 3 on both sides. We get 2x equals 8. Last, we'll divide by 2 on both sides, and we get x equals 4. So x is 4, y is negative 1. That's where our two lines would meet when they're graphed. All right, one last example. So again, this example does not have opposites. However, what we are going to need to do is multiply both equations in order to make opposites. So for this one, we have 3x and negative 2x, and we have 4y and 3y. So both of these, if we try to multiply the smaller number by a number, we wouldn't be able to get the larger number. So we have to multiply both equations in order to get opposites. So for what I like to look for is, do I already have a positive and a negative? So here I have a positive 3 and a negative 2. So we already have one piece of that opposite. So since we already have the positive and the negative, I'm going to say 3 times 2 is 6. So my goal is to get 6x and negative 6x. So I'm going to multiply the top equation by 2, and I'm going to multiply the bottom equation by 3. So we do that. 2 times 3 is 6, 2 times 4 is 8, and 2 times 8 is 16. Do that on the bottom. 3 times negative 2 is negative 6, 3 times 3 is 9, and 3 times 6 is 18. Now we can add up our equations. 6x plus negative 6 cancels out, that eliminates. 8 plus 9 is 17y equals 16 plus 18 is 34. We can finish solving that equation by dividing by 17 on both sides, and we get y equals 2. So in our coordinate point, our y value will be 2. And now we need to solve for x. So again, we can choose the top equation or the bottom equation of our original equations. So I will choose the top one. So we have 3x plus 4y equals 8. I know that my y value is 2, so I'm going to replace y with 2. And now I'm going to solve this equation. 4 times 2 is 8. So we have 3x plus 8 equals 8. Subtract 8 from both sides to get x by itself. We get 3x equals 8. Take away 8 is 0. So then divide by 3 on both sides, and we get x equals 0 divided by 3 is 0. So our coordinate point would be 0, 2. That is all the notes for you. You can go ahead and move into your practice.